This video is going to cover fermentation, which is a chemoorganotrophic catabolic process that happens entirely in the cytoplasm and does not require an electron transport chain. So fermentation starts with glycolysis. I know that you're shocked by this. So you can use any glycolysis to start fermentation. I have just re-put the EMP glycolysis slide because, again, it happens in all cells and is the one that you would have learned about before. So fermentation can be a little bit tricky because sometimes it's the name of the process and sometimes it's the name of the step. We are only going to use it as the name of the process. So we're going to talk about the process of fermentation, and then we're going to talk about the step of NAD plus regeneration. This will help us to be less confused. So the different glycolysis pathways will take us from glucose to pyruvate. They will, well, the first two, EMP and interdeuterov, produce NADH along the way, right? So as bonds are broken, the electrons are picked up by the NAD plus generating NADH. This makes a couple of ATP for the cell in EMP through substrate level phosphorylation, and again produces pyruvate at the end. So there might be a situation in which the cell needs to free back up these NAD pluses. So if it's done a bunch of glycolysis, then it's got a huge number of NADHs, and if the electron transport chain is not running, maybe there's no external electron acceptors, or the electron transport chain is not running efficiently, because so normally the stop for this NADH would be the electron transport chain, the NADH would drop off the electrons, and then NAD plus would be recycled. If something has gone awry with the electron transport chain, then the cell is just stuck with this massive amount of NADH, and it has no way to rerun glycolysis because there's no NAD pluses. So it needs a way to regenerate NAD plus, okay? So this is the cell. This is what it's got. Nothing, pretty much. It's got nothing. What it does have, in addition to lots of NADHs, is lots of pyruvate. So the cell is like, aha, I will give my electrons to pyruvate, and then I can regenerate some NAD plus and run more glycolysis. And that is exactly what happens. And so fermentation is distinguished from respiration processes because it uses an internal or endogenous electron acceptor, and this is going to be a compound that has been produced by the cell as part of a normal metabolic pathway. So it is not an external compound to the cell. It is an internal compound for the cell. Most commonly, it is pyruvate. And so the electrons will go from NADH to pyruvate, thereby regenerating NAD plus and making some miscellaneous organic compounds. So fermentation, the process, requires an endogenous electron acceptor. It happens in the cytoplasm, right? So there is no electron transport chain. If any ATP is made, it's usually only made up here, and would be made by substrate level phosphorylation because there is no electron transport chain. The other thing that I want you guys to think about is that this is still a partial oxidation, right? So pyruvate has 3 carbons. If you give it more electrons, then it is going to want to form a new bond. Possibly it like makes a bond and then breaks in half or something, right? That's where we get like acid and gas, is makes a bond and then breaks off the CO2 as its other thing. But we still have some carbon to carbon bonds here, and so even though this initial cell may or may not be able to use lactate as a food source, there will definitely be some bacteria somewhere that will be able to use lactate as their energy and electron source because it is only a partially oxidized organic carbon compound. Hopefully that makes sense to you. If there are any carbon-to-carbon bonds remaining, then additional energy and electrons can be harvested. This little chart here shows you, you can just kind of look at it, shows you all the different things that are produced. And so bacteria can make alcohols, not as common though. You'll see these little like blue splotchy things are alcohols. Yeast actually makes alcohol much more commonly than bacteria. Bacteria will most commonly make acid, which are these pink boxes, and gas, which are these circles. So sometimes they make alcohol though. Okay, so key differences between respiration and fermentation. Is oxygen required? Well, right, so this is going to depend. So if it is aerobic respiration, then yes. If it's anaerobic respiration or fermentation, then no. So it's just going to depend. What is happening with the carbons? And so again, we have so far only talked about glucose, so we're going to go from glucose to pyruvate to something. Let me see, I can write over here. In respiration, we always go completely to carbon dioxide. In fermentation, we can go to carbon dioxide and acid, the acid and gas, or we can just go to acid, or we can just go to alcohol. So respiration is a complete oxidation process. Fermentation is an incomplete oxidation process. So another bacterium can use the fermentation product as an energy and electron source. The initial electron donor for all three of these is glucose. The final electron acceptor, again, so for respiration, we have an external electron acceptor. It's either going to be oxygen for aerobic or not oxygen. Often inorganic, though, for anaerobic. Whereas fermentation will have an internal or endogenous electron acceptor, often pyruvate. The electron carriers are the same in both, so NADH, sometimes, we won't write that, it'll just confuse you. NADH and FADH2. ATP is made in both if you consider fermentation the process to include glycolysis. In respiration, we use substrate level and oxphos, and so we make lots. Relative amount is like some, none, or lots. It's not actual numbers. So respiration makes lots of oxygen and some, if not oxygen. Fermentation can also make ATP, but it's substrate level only, and so it's going to make just a little ATP. So that is fermentation. Just as you guys should be prepared to interpret something like this in the future. Right? So it could be because you just understand that pyruvate is accepting the electrons, or you could be able to answer this because you understand what reduction is. But there will be some, either what is being oxidized here or what is being reduced here, equations on the exam. Do you guys remember we had one of those the other day as a clicker question? So just be on the lookout for those.